now talking about conic section ellipses. So yesterday we were talking about circles, and when we have a circle, we divide the cone, we slice the cone perpendicular to the ground. To get an ellipse, we slice the cone at an angle. So we see how we get that ellipse by slicing at an angle. So we have a different equation when we do that. We know that an ellipse is an elongated circle, and it's a little more complex. So let's dig right in. What is the equation for an ellipse? We have, it's similar to a circle, so that's why we're doing it next, and we have x minus h squared plus, let's look at the similarities, y minus k squared. Now, we have x minus h is over a squared, y minus k is over b squared equals 1 if we have a horizontal ellipse, okay? So then when we have that, our center for a horizontal ellipse is going to be, as you would guess, h and k. And then our vertices, which is the ends of the horizontal ellipse, is going to be left and right from the center. And it's going to be a units right under the x, a units from the center. From center. Our co-vertices, so we're looking at the picture, so I'm going to slide this up a little bit. We have a horizontal ellipse. Our co-vertices are on the y-axis, and they are going to be up and down. And you were going to guess right, b units from the center. From center. From center. And the foci are going to be along what we call the major axis. Okay, this is the major axis. And of course, on a horizontal ellipse, that's where we find the major axis. And C units, I'm going to color them in a little bit deeper there. This are going to be left and right. C units from center. From center. So we see already how this is getting a little more complex. Okay, so these are co-vertices. Co-vertices. Right here are our vertices, and these are our foci right there. Okay, now let's look at our vertical ellipse. So as you would guess, we have a center at HK. We have vertices, I'm going to over here, and they are going to be up and down, A units, A units from the center. Okay, we notice that the A is under the Y at this point, okay? Let's note something. A is always bigger. So that's one way we can tell whether we have a vertical ellipse or a vertical ellipse or a horizontal ellipse. Which axis is longer? So when we have a vertical ellipse, the A is under the Y. When we have a horizontal ellipse, the A is under the X. Okay, the co-vertice is left and right from the center. Left and right B units from center. Okay, and because our major axis, let's label it, this is the major axis, is on the along the y-axis, then our foci are going to be up and down, C units from the center, So let's label that. So we are going to have, these are our co-vertices right here, so let's label that co-vertices. These are our vertices, and we don't really have them labeled here, so let's just draw them in. These are going to be our foci right here. Okay, so you get the idea? Okay, let's move on. We have an equation, center, vertices, co-vertices, foci, and all. There's their graphs. Okay, so let's move along. And best way to understand is examples. Okay, all right. Example 1, let's graph an ellipse. Let's graph an ellipse and state the properties, okay? All right, so we have 2 ellipses here, and let me make sure I'm on the graph. Okay, we have an ellipse, and what characterizes an ellipse? We have a plus in the middle. We have a center here. Let's label what is A and what is HK. So we have a center at H, which is always associated with X, 1 and 2. Okay, what is A? A is always going to be the major axis, so A must be the larger one, so A is going to be 4, right, because it's the square root of 16. A is 4. What is B? It's the square root of the smaller number, so B is going to be 3. Okay, what is the foci? Well, we don't know yet, right? So we have to figure out, what is C? Well, let's start with something a little bit easier. What are the vertices? Well, the vertices are going to be, we can find that most easily by graphing it. So let's start with the center. 1, 1, 2, 1, 2. There is my center. And I know that this is going to be a vertical ellipse because the long axis is along the y, because the A is under the y. So let's go 4 up from the center, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. So let's write in the vertices. 1, 6 is one of my vertices, and 1, negative 2 is my other vertice. 1, negative 2 is my other vertice. So there we have the vertice. Now let's talk about the co-vertice. So I have the center, and I have B as 3, so I'm going to go 3 to the right, 1, 2, 3, and 3 to the left, 1, 2, 3. Okay, now I have my ellipse. Now I'm going to say co-vertices. Let's look at what we have. We have 4, 2, and negative 2, negative 2, negative 2, negative 2, and those are my co-vertices. So now let's draw this in first before we go any further. I'm drawing this in, and I am going to then, I want to find my foci, so what do? I need to calculate C if I want to go any further. So how do I do that? Well, I remember my equation on the first page. On my first page I said my C squared equals A squared minus B squared. So let's go back to that. C squared equals A squared minus B squared. Well, I know what my A is. C squared equals 4 squared minus 3 squared. That is 16 minus 9. So C squared equals, move this up so we can see it, 5. So what do I do to solve? I take the square root of both sides, and I get C equals the square root of 5. So where do I label that? Well, I know, again, it looks almost like a circle, but I know that my axis is this way, so my foci is 1 plus the square root of 5. So I'm going to get my calculator and say, what is that? So turning that on, maybe my calculator is not turning on. So go get that calculator that will turn on. Excuse me, sorry about that. So let's get that. We have, let me see that. We have 1 plus the square root of 5, and that is 3.23. So I'm up here at 3.23 for 1, and then I need 2 plus the square root of 5. So my center is at 2 plus the square root of 5. Wow, I'm having a rough day here. 2 plus second square root of 5, and that's 4.23. So sorry about that. 4.23. That is foci, and then 2 minus the square root of 5. 2 minus square root of 5 is negative 0.23. Negative 0.23, and that's the second. So we have 1 4.2 and 1 negative 0.2. Those are the foci. Okay, so that gives me this ellipse, which is starting with this center. Okay, so let's do another one. So we start with the center, which is h negative 1, k 3. What is a? A is always the long side, so a is 3, and b is 1, the square root of this. Now, which is this, a horizontal or vertical? Well, this is going to be a horizontal ellipse. So let's just write that. This is a horizontal ellipse. This one was a vertical ellipse. Okay, let's start with the vertices. The vertices are best figured out if we graph. Let's start with the center. Negative 1, 3. There's our center. Let's start with A. We're going on the x-axis. 1, 2, 3. 1, 2, 1, 2, 3. So our vertices are going to be negative 4, 3. And 2, 3. 2, 3. Those are our vertices. Now our co-vertices are on the y-axis, and we just go up 1. There we go. And that is going to be negative 1, 4. And negative 1, 2. Excuse me, negative 1, 2. Said it right, wrote it wrong. Okay, now let's draw our ellipse. Okay, draw that right in. Okay, there's our ellipse. Now, the foci are a little bit more challenging, so we need c squared. We know that c squared equals a squared minus b squared. We know that a is 3 squared minus 1 squared, which is 9 minus 1, so c squared equals 8. I solve by taking the square root of both sides, just a little bit, and I get c equals. Now, I can simplify that just a little bit, right, remembering that this is 4 times 2. What's the square root of 4? Well, that's 2, radical 2. So now I know that c lies on these axes, so c is going to be negative 1 plus 2 radical 2 and negative 1 minus 2 radical 2. So I'm going to take my calculator. I'm going to start with negative 1 minus 2 radical 2. So, all that, we have negative 1 minus 2 radical 2, and that gives me negative 3.8. So, I have negative 3.8, and then I'm up here on the y-axis at 3. And then I have negative 1 plus 2 radical 2. and I get 1.8. So I'm going to be at 1.8 and then up at 3. So that's where the foci are. So I'll just draw that in, negative 3.8 and 1.8. 1.8, so there we go. So there we have our vertices and our foci and the center, and here we have the co-vertice. Okay, so we see where everything is on our ellipse. Okay, so let's move on a little bit. Now, sorry. This is, we're working on an ellipse. Sorry about that. All right, we want to take, if we're given certain information, like the foci and the vertices, we want to transform this information to write an ellipse in standard form. So how do we go about doing that? Well, we take what we have. We know that, the graphs will help. So let's write what we have. We have 0, negative 2 is a vertice. A vertice tells us that this is the major axis. So then we do the other one. We go over to 6, negative 2. Okay, so if this is the major axis, then we know that right in the middle is going to be the center of the ellipse. So we say that we have between 0 and 6. So at 3, negative 2 is our center. So let's go up and write that down. We have a center at 3, negative 2. Okay. Now we know that the foci are at 2, negative 2, and at 4, negative 2. So what does that tell us? We know that our formula is c squared equals a squared minus b squared. Well, we know that the distance from the center to the vertice is 3. So that tells us that our a equals 3. 3 squared equals, we know that c is the distance from the center to the foci, so that's going to be 1. So we know that c squared is 1 squared. So we have to solve for b squared, which will tell us the other side of the ellipse. So we can do that. 1 squared is 1 equals 3 squared, which is 9, minus b squared. Okay, solve for b. Minus 9 minus 9. We're just using algebra. We're taking 9 from both sides. Negative b squared equals negative 8. Let's divide both sides by negative 1. Solve for b squared. We're just using algebra. B squared equals 8. Solving again. Take the square root of both sides. B equals the square root of 8, which is, I can divide that up into radical 4, radical 2 is 2 radical 2. So, or I can leave it the square root of 8, either way, which is probably easier. So let's scratch that and just leave b as the square root of 8. Okay, now, because all I really want is the standard form. B is the square root of 8. I have the center, I have a is 3 and b is the square root of 8. So I can write the standard form. Okay? An ellipse is plus this times this equals 1. So what's the standard? Let's remember the standard form of our ellipse. We remember that we have x minus h. What's our h? 3. So x minus 3 squared over, let's finish drawing our ellipse in. We know that we have a center here, and what was our a was 3 squared, which is 9. And then we have y minus this other center, the k, y minus a negative 2, which is y plus 2 squared. And then along, this is going to be b squared. What is the square root of 8 squared? Well, that's going to be just 8. Okay? So there we have everything we need. We now have the whole standard form. Now, just because we know that this is 1, I want to finish drawing this. So we have the center, it goes up 1, goes up 1. We know that, I'm sorry, b was the square root of 8. What's the square root of 8? It doesn't go up 1. Second square root of 8 is 2.8. So let's just go up 2.8. It's almost 3. 2.8 is almost 3, so I can draw in an ellipse that is almost 2.8. So that's the size of our ellipse, because the square root of 8 is approximately 2.8. So that's how I drew that ellipse. Okay, let's do this again. And then I'm going to let you do 5 and 6 on your own. Oh, I know, I'll let you do those two by your own. Okay, vertices are negative 2, 3, so that's the long side, negative 2, positive 3, and 6, 3. Co-vertices are 2, 1, and 2, 5. So what does that tell us immediately? That the center, let's write the center is 2, 3, 2, 3. So what is A? A equals the length from the center here, so that's 1, 2, 3, 4. A is 4, and B equals 2. So now I pretty much have everything I need. I can draw my ellipse, and I have everything I need to write the standard form, right? So x minus 2 squared over the x is 16 plus, ellipses are always plus, that over, y minus 3k squared over, what's the y? That's going to be 2 squared, 4 equals 1. So there is the standard form of my ellipse. Okay? So I'm going to let you do 5 and 6 on your own, and then I will do one of these for you. So let's review how we did this problem. We group all the x and y terms together. So we do 4x squared plus 24x, leave a little space. We have plus 25y squared minus 50y. Now we're going to complete the square, so we're going to move this term over to the other side. How do we do that? We add 39 to both sides. So we're going to add 39 to the other side. I'm going to add it to both sides. Now, it says here, factor out the greatest common factor for the x terms and the y terms. So watch carefully. What I'm going to do is I'm going to factor out the 4x squared. What is 24 divided by 4? Well, that is 6x. Now, what I'm going to do is I am going to have to multiply 4